Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we take a look at simple linear regression. We'll demonstrate it using JASP, and as we do, we'll come to appreciate its application when it comes to research. Now, we know you really enjoy our videos, and we encourage you to subscribe to the channel if you are new to the channel. Turn on the notifications so that you will always receive videos whenever they are released. We also encourage you to like the videos, comment as much as possible, and share with all that would really benefit from these tutorial videos. Today, we look at simple linear regression. Now, simple linear regression tells how an independent variable predicts a dependent variable. A dependent variable is simply an outcome variable. In this case, we can say BMI level. And an independent variable is an exposure variable. In this case, we can say physical activity. So we want to know how physical activity predicts BMI level. And since BMI and physical activity are continuous variables, we can use a linear regression for that. Now, if you don't know how to select which linear regression or which regression to use, we encourage you to watch our video dubbed Regression Analysis. That will help you to know when to use a simple regression or a multiple regression, a linear regression, or even a logistic regression model. And even how to evaluate a model that has been built using a regression analysis. What kind of model is a simple linear regression? It is basically a linear regression model with a single predictor variable. What does that mean? It means that it involves just the model involves just two-dimensional sample points, with one being the exposure variable and the other being the outcome variable. Now, whenever we are doing a simple linear regression analysis, there's a hypothesis that we test for, and that hypothesis is that there is no significant prediction of the outcome variable by the predictor variable. In the example above, or the example we gave earlier, we can read the null hypothesis as the fact that there is no significant prediction of BMI level by the physical activity or physical inactivity or physical activity. Now, one take home is the fact that the adjective simple added to the simple linear regression refers to the fact that the outcome variable is related to only one predictor or exposure or the independent variable. Having established this theoretical basis or background against the simple linear regression, we now want to go to the JASP platform and see how we can soil our hands with some practice. So let's go to the JASP platform. So we are currently on the JASP platform. We'll click on this and then open our data library. And then we'll come to regression and then select the data set that will help us achieve what we have been discussing here in physical activity and then BMI. Now, when you scroll this here, it gives you how the data set looks like. We have subjects, we have PA, which is the physical activity, and BMI, which is body mass index. And then their concomitant values are there spelled out. Now, when we go to the description of the data set, it says that this data set, physical activity and BMI, provides participants' body mass index and average daily number of steps, the variables, subjects, PA, BMI. This example JASP file demonstrates the use of linear regression. Specifically, we can investigate whether and to what extent the average daily number of steps relates to BMI. Now, when we go to the descriptive statistics, we have opportunity to test to see whether our data set is normally distributed. We rarely establish that when our data set is normally distributed, then we can use the linear regression model. And so from the Shapiro-Wilk normality testing, we realize that our data set is normally distributed because the p-value is not significant. And looking at the visual inspection, this looks quite normally distributed, following the normal Gaussian distribution, as well as this. Now, when we go to the linear regression, we realize that our independent variable or the outcome variable of interest is BMI. And then the independent or the exposure variable is physical activity. Now, this gives a summary of the model, the R squared, the adjusted R squared, and then the RMSE. Now, the explanation of this is that the physical activity explains about 15% of the variance in the BMI. Now, when we go to the ANOVA, where we have the model evaluation, it helps us to see the F statistic, which helps us to be able to tell whether our model is performing better or not. Now, the p-value is significant, that is less than 0.01. The F statistic is 17.10, which is quite large. Now, the interpretation, the linear regression model is significantly better than the null hypothesis. Now, when we come to the coefficients, this has the intercepts, and it will be able to help us to be able to generate an equation that links BMI to physical activity. And here it gives us an expression in that regard. So BMI is equal to 29.578 minus 0.665 times the PA value, which is the physical activity value. Now, where did we get these values from? Now, when you look at the table, we have the intercept. So basically, this is following the equation y equals mx plus c. Now, the m is the gradient, and then this is the intercept. So we have the intercept here as 29.5, which is expressed to 2 decimal places. So that is why this is 8. So we have that here. And then we have the and this is the regression coefficient or the gradients in simple formulas. And that is this value, negative 0.665. So that is what we have here. So basically, this is an equation that we can generate to predict that particular line. This is what we are seeing here. So basically, this is how we can employ simple linear regression to be able to predict how two variables relate and how one predicts the other. This is Catalytics. Until we meet again, it's a bye.